Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings and I'll be introducing you to Python today. We're a meetup group that and we do this every week. On the first week of every month, on a Tuesday, we try to do an absolute beginners session. So this is what this one will be, and it's designed for people who've never seen Python before. Although we do, so we don't have to do exactly the same thing. On the first week of every month, we do introduce different concepts on different times. So if you've done the other first weeks, then you'll still probably learn something from this one as well. But don't be afraid, this will be suitable for first timers. So if you've got any questions, feel free to ask. I'll be listening to the YouTube chat, which is next to this video, and also on our Slack channel in the Learning to Code channel. You can ask questions there as well. So today, we're going to, because it's absolute beginners, we're going to assume you don't even have Python installed on your computer. And so we'll be using Google Collab, which is a way of running Python that allows it to run on their server, and so you don't need to install anything, it's all web-based. It's also a very good introduction for people who are doing data science because a lot of them will just use Google Collab all the time. It uses Jupyter Notebooks, which is a way of presenting Python. For other people who want to write Python programs, I recommend that you download Python from python.org. Just grab the latest version, like 3.8.5, and install that onto your computer. And you'll probably also need an IDE, a development environment, which is a bit easier than the standard one that comes with the Python. So the one I recommend is JetBrains. I've got one called PyCharm, and they've got a community edition which is free and plenty powerful enough for everything that that I use. So there it is there, PyCharm. So if you install Python and PyCharm, you'll have a good way of writing programs. But if you're wanting to do data science stuff, you might find that Google Collab is good enough for you. Okay, so to use Google Collab, you'll need to have a Google account. So hopefully you've got one of those. Now I've provided a template notebook here, and the link is on the YouTube page, and it's also here on the Meetup page. So if you click on that link, it will open up a copy of the notebook that I've got. So it's got all the content for today. It will include some tasks, and you can actually work in the notebook itself and type things in and get results. But if you want to save them, we have to save a copy because this is my one here. So to do that, go to the File menu and save a copy in your drive. And that will create a copy for you. And you'll see that in the title it now says copy of Meetup 75 Beginner Dict and Functions. So this is a notebook, and you'll see it's made up of cells. So this rectangle here is the first cell, and that's just got some markup in it, some text in there that you can read. It tells you what we're going to do today. We're going to learn how to use Python Dictionaries, which is like a list on steroids. You'll be able to store values of data and also specify how to retrieve that data later. We'll also talk about functions. It follows up from Meetup 67, which is really getting started 1. This is probably more getting started 2. So if you're really lost in this one, maybe go back to Meetup 67 and watch the video on that one before you watch this one. But I'll try to recap everything and definitely ask questions. So this here is the second cell. It's telling us what to do. To run a cell, you type Shift and Enter. You want to have a look at some of the other commands you can do in Google Collab. You go up to the Tools menu and have a look at the keyboard shortcuts, and that'll tell you what the keyboard shortcuts do.
Here's Here's what I found on the web.
So we'll select this cell here, it's the third one down, and I put a little bit of Python code in here, and all this bit of Python code does is tell us what version of Python we're using. So to run that, we put the cursor, we click in the cell, and we can see the flashing cursor there. We've got a play button here, so we can press play, or I can press, I do Shift Enter, and that does, it says also Control Enter would work. Now the very first time you run something in Google Collab, it will be quite slow because it's got to load in up all the Python behind the scenes. But once it's done that, everything else we do should be a lot faster. So here we go. Don't worry about these commands for the moment, but it's telling us that we're running Python version 3.6.9, and that's really all we really need to know about it. Okay, so when you're using a programming language, you want to store data in variables. You want to store data. So we store them in variables, and variables can have names. So I've given these variables some names. And so the first one here I've called myInt, and that's just a name that I've made up. And then by putting an equal sign and then a value, it stores that value into that variable. And then at any time later, I can look at that value by using the variable name. I don't have to remember the data that's in there. So to run this cell, I'll do the Shift Enter, as I've done before, and nothing happened. What it's done, it's stored all these bits of data into these variables. So I've put an integer into a variable called myInt. I've put a floating point number, you can see the decimal point there, into a variable called myFloat. I've got a Boolean, and Booleans are true or false, and I've put that into a variable called myBool. Here's a string, so I've denoted the string by putting quotation marks around it, and a string is a bunch of text. So if you want to store text in a variable, you can put quotation marks around it. Now with Python, it's got many different types of, you can use single quotes, you can use double quotes. They both work for defining strings. In this case, I actually had a single quote in my string, so it made sense for me to use double quotes to define the string so that it didn't think that when it got to this single quote that it had got to the end of the string. So I'm going to run this. I did run this before, so I'll run it again. And now I want to have a look at the values of those variables. So when we're using Jupyter Notebooks, we just have to write down the name of the variable, and the last thing that we put in a cell, it will evaluate and it will display what the result is. So in this case, I've put two things in here. I put my string and my list. And if I run this one, my string doesn't get displayed, but my list does. And you can see it's a list. It's got square brackets around the outside, and it's got a bunch of different values in there. It's got 5, 5.0, true, beginner's Python and machine learning. And you can see how we put data into my list up here. We created the list by using these square brackets, and then we used the variable names that we previously created, myInt, myFloat, myBool, and myString, and stuck them into that list. And so by using the variable names here, it's actually put the data into that list, and now I can look at the data in that list. So I'd recommend at this stage to try to create yourself a couple of cells. So Control MB will create a cell below this one. Let's try that again. Command MB. There we go. Or I could have gone up here to the Insert menu, and I said Insert Code Cell, and you can see I use Command M and then a B, or you can, in Windows, you can use Control M and a B. So that's created an empty cell, and in that cell I can type a variable name and it displays the value. Or I can change that to my bool and it displays what the value of my bool is. But as we saw before, if I do my bool on one line and my float on another, it only displays the value of the last one. So Jupyter Notebooks is what we're in at the moment. It's also an extension over IPython. So IPython looks a bit similar to this with these square brackets showing what number cell we've just run and putting the results just below it. Python console is another way of doing this interactive Python way of doing things. And you'll notice that you'll see that'll have 3 greater than signs ready for you to type in stuff, and then it displays the results after that. So this interactive is a really good way of learning. So I really encourage you to try typing things in and just seeing what your results are. And even when I'm not sure how something will go, I jump into interactive Python, type something up, and it executes straight away and shows me the results, and so I can see how it's going to work. However, some people may not be going to use interactive Python, so I've designed all these exercises to also work with just straight Python without using interactive Python. And so to do that, I've used print commands. So doing, I can, if I want to display the results of my bool, I can do a print command there, and if I want to show my float, I can do a print command there. And the other advantage of using print is that even in Jupyter Notebooks, it means I can now put 2 results and I'll get both the results because each of those print statements will be executed and show me the results of that data. Now, when I'm printing, I'm starting to use format strings quite a lot in these demonstrations. It gives me a much nicer output, and the way I use format strings is I put an F outside the front of the double quotes or the single quotes, and that means that anything inside this string, if it finds these curly braces, it will evaluate what's inside the curly braces and then display that value rather than the letters my int. So if I run this cell now, we can see this first print command here. It says printing using format strings, and it's done that, printing using format strings. And you'll notice it doesn't show the double quotes in this case, even though when we're doing this without print, it does show double quotes. And that's because you would normally want to use print for displaying output to users, end users, who are not interested to know whether something's a string or a integer or a boolean. And so it's evaluated each one of these variables inside the curly braces, and it's put the value next. So my int is 5, my float is 5.0, my bool is true, my string is beginners Python and machine learning, and my list, which you can see with square brackets, is got 5, 5.0, true, beginners Python and machine learning, and my tuple, which you can see with the parentheses, has got the same values in it. Now my tuples are very similar to lists. They're like a read-only version of lists. So there's a couple of cases where you're better off using a read-only variable, a read-only data type, rather than a data type that you can manipulate. And in that case, you would use tuples rather than lists. So with lists, you can do things. You can add extra things to the end of the list. You can delete items out of the list. But with tuples, once you've defined it, the only way you can change that data is to put a completely new tuple into that variable. All right, so feel free to ask questions as we're going along. I will share this notebook's URL so that if there's anything that I've typed during today's session, then you can load this URL, and in just reloading it, you'll get the new stuff that I've typed and saved. So I'll paste that onto the YouTube chat, and I'll paste it onto the Slack channel as well. So let me know if there's any problems. I've done that now. Let me know if there's any problems with that coming up. Okay, I've got a question. Fantastic. What is the meaning of the F? So F means this string is a format string. Now, when you're defining Python strings, so let's create a couple of cells below. You can have a string. This is a string, okay? But sometimes you'll want to specify something more or about the behavior of the string. So there are 4 letters that you can put out in front of a string. They are F, B, R, and U. Okay, so you would have 1 or 2 of them. You can't have all of them. So F, this means it's a format string. And what a format string does is it looks for curly braces inside the string. Now you see, if I don't have the F there, the curly braces are red, and they're just treated exactly like normal curly braces. But as soon as I put the F there, then the curly braces get a different color in Google Collab, and it means that now I can put an expression in there for it to calculate. So I can say 5 plus 6 plus 7, and the string is now, this is a string 18. So by putting the F here, it means I can put an expression inside curly braces, and it will evaluate that before it returns the string. So the advantage up here of doing that is I can put these variables in, and I can see what the variable value is as well as the variable name. And in Python 3.8, I can even type things like my float equals, and it will print the variable name and the variable value. But in Python 3.6, which is all that's on Google Collab, I can't do that. So that won't work. But I can just do my float, and it will give me the value of the float there. All right, the other things that you can do in front of strings, you can say U for this is a Unicode string, but that's the default on Python 3 anyway. So there's nothing special about that. But if you're wanting to write code that works on both Python 2 and Python 3, then you would have to put a U there so that Python 2 also knows that it's a Unicode string. Similarly, the default on Python 2 is a byte string. So if you want to use byte strings in Python 3, then you have to put the B out the front. And the last one is the R is for raw strings, and raw strings basically mean don't escape the backslash, because we normally use backslashes for putting in special characters, but sometimes when we actually want backslashes in the string, then it's easier to use a raw string, so we would put an R, and so I can put an R on this one as well, in which case I can then do things like that, and those backslashes will just come up. Invalid syntax. Let's try that. Doesn't like /R. So, in I'm not sure why it didn't like those other ones. /t should work. Yep. I didn't like the U and the R together. Anyway, I thought you could do that. But so you can see here, with an R out the front, then the string looks like this. If you don't have the R out the front, which is how, then all of these backslashes have to be escaped to get that string. And if you didn't have the R there, and you only put single backslashes there, then you would get there's Google Collab having a bit of struggling with this a bit, but that should not show the backslash n. Well, I won't spend too much time on that, but that's what the R does. Okay. No more questions? Good. All right, so still recapping on Getting Started 1, some of the, we'll look at our list here. So this is a list of strings, so we've defined it with square brackets here, and we've got, we've put all the numbers in here as words. And now we've got a loop. We're using a while loop. And so we're going to increment I, and while I is less than the length of that list, we're going to print out the value of I, and we're also going to look at what's at index I in numbers, and these indexes are 0 based. So let's run this and see what we get. So 0 is I equals 0 returns the word 0, and that's because it pulls it out of the list like this. I equals 1 returns 1, I equals 2 returns 2. So by using a list like this, we've now got a convenient way of converting any numeral digit into a name. And this is really good, except for doing the numbers 0 to 20, but what if you want to do numbers that are outside 0 to 20? Well, we could increase the size of the list by adding 21, 22, 23 onto it. And the way we can add to a list, we can use plus equals. So plus equals is saying like numbers equals numbers plus another list. And when you add two lists together, it concatenates them. So let's have a look at what we get when we do that. So we get 0, 1, 2, and you can see on the end here we've got 21, 22, 23. But that doesn't scale very well. It does work for, say, if I put in I equals 22 and run this print command, 22 gives me 22. All right, so but that's going to make a very big list even if I just want 100 numbers. So we're going to delete the last three numbers from this list. I can do that. I can do a slice, and this is just a recap of Getting Started 1, but feel free to ask questions about it if you want. I want to delete everything from the third last number to the end. So I do -3 for third last, colon to the end, and I run them through the delete function. And let's have a look at numbers after I've done that. You can see that it now goes up to 20 and doesn't have 21, 22, 23. What would be more useful for me is to just store the tens, because I've got all the units here and I've got the special cases up to 20. And then if I just store the tens, I should be able to construct a number for any number up to 100. So let's have a look. Tens, it's a list. It's got 20, 30, 40, 50, 60, 70, 80, 90 in it. And remember, this is indexed, so that'll be 0, 1, 2, 3, 4, 5, 6, 7. So to call up 20, I just look up tens and square brackets 0. So if I want to use our numbers list and our tens list to construct the names of these numbers, all I've got to do is find out how many units there are, find out how many tens there are, and then add them together and put a dash between. So to find the units, I use modulo arithmetic. So I%10 says divide I by 10 and give me the remainder. And so for 27, that'll be I%10 will give me 7. And then left, to give you the left number, will be just I minus what the right number was. So 27 minus 7 will give me 20. So once I've got 20, that's for the left number. If I divide it by 10 and subtract 2, I'll get 0, and that'll give me 20 here. So that sounds good. Let's see what happens when I run this. So 27, it gets broken up into 20 plus 7, and so the name of that is 20-7. So that looks like it's working pretty well. Similarly, 52 gives me 50 plus 2, that's 50-2. Very good. But then I've got a couple of cases here that don't work so well. And that's 5 gives me 0 plus 5, but 0 divided by 10 is 0 minus 2. It gives me minus 2. So when it finds the left number, it's counting backwards from the end of this list of tens and giving me 85. Similarly, this gives me 92. And the last case that doesn't work is 30, 0. So our first task today is fix the code so that all the numbers are displayed correctly. Now I'm getting some questions about what's these format strings, which is a very good question. So when you put in the curly brackets, you put a colon. Anything to the right of the colon is a format for how you want that value to be displayed. So the 4 there says that I want it to be 4 characters wide, and that's, so here we're looking at this number here. So that has got a space there of 4 characters, and so it's going to print I, and it's going to print it in 4 characters if it can. If it can't fit it, it will expand that space, but then it will mess up the formatting for everything else, but the full number will show. Okay, the greater than sign says I want, in that 4 characters of space, I want it to be right justified. So that will align it on the right. So I could have used a less than, which would be left justified, and or I could have done circumflex, which is centered. And the D says I want it to be printed as a decimal number. So decimal is base 10, and so that will do. So I could change that to, I want it to be binary, I want it to be 8 characters wide, and I want it to be centered. And so now it's converted them all into binary numbers, it's centered them, and it's left 8 characters for that job. But that's not much use for us in this case, so we'll go back to, well, I'll leave it like that for now. But it's greater than 4D was what we had there before. In fact, I'll do it both so you can see, compare them. Now these format commands are, they're a little bit confusing and hard to remember, but they're very powerful and useful. So I use them as much as I can so that it helps me remember them for the next time I want to use them. Okay, so our task today is fix the above code so that all the numbers, all the names of numbers display correctly. Okay, so I'm going to copy this code here into a spare cell that I've left for you. So you can either watch how I solve it, or you can pause the video and have a go at solving it yourself. I've got a hint here on how we do conditions. We do testing in Python. We can have an if and then a condition to test for, and then we put a colon. And once you do a colon, then everything after the colon needs to be indented, and anything in that's indented is called the code block. So everything you want to happen when that condition is true is indented the same amount here, and that will happen all the way until it gets to the first command that's not indented. Then we've got an else if that's linked to this if. So if this, else if this condition 2. So the code in here will only happen if condition 2 is true and condition 1 is false. And then that's the second code block, and then the third code block is for the final remaining condition, which is both condition 1 and condition 2 are false. Okay, so what are we testing for? We need to check if the numbers are less than 20. Okay, so if I is less than 20, and I typed the colon, then I pressed enter, and you can see that Google Collab has automatically indented for me. So it's indented 4 spaces for me. I think that might be a setting I've set in Google Collab. For other people, it might indent 2 spaces. Just be consistent in your spacing, and you'll find most Python style guides say 4 spaces at the moment. But yeah, if you're happy with 2, then just leave Google Collab with those settings. All right, so in this case, if it's less than 20, then we just have to do numbers right. We don't need to do anything else. So the next thing, evenly divisible by 10. Okay, so evenly divisible, what we can do to test for that is we can divide by 10 and see if its remainder is 0. So we use modulo for that. And we see if that equals 0. Once again, it's indented automatically for me. I just pasted because it still remembered that. In this case, we don't need numbers right. We just need the 10s. Okay. And then in all other cases, once again a colon, and then I have to indent, otherwise it won't work. There has to be a code block under here after you do a colon, otherwise it'll give you a syntax error. And let's try that. No, I've still got the binaries in there. But anyway, so 27 looks good, 52 looks good, 5 looks good, 12 didn't work. So if I is less than 20, yes, so fix up that one. We just can do numbers I, and 30 is 30 plus 0 gives you 30, so that's correct. So let's run this now that I've changed this to numbers I, and the 12 is now correct as well. So let's look at the solution. I is less than length numbers. So that's just a more general way of doing it. I've hard-coded the 20 in there, but if for some reason I wanted to put numbers up to 30 in numbers, then this would quickly just go straight to using that. So that's probably a better way of doing it, so that any change in your code later doesn't get you don't have to change code in two places. This will automatically correct for that code change. Else if right equals 0, okay, yeah, well that's correct. We've already done I modulo 10 there, so I could have just used what the value of right was and compared that to 0, and then the else was the same. So are there any questions about that task? So you'll notice we're using integer division here with the slash slash is integer division, single slash is floating point division. So integer division gives us the floor of the value by doing that division. So 25//10 will give us 2. And then we subtract 2 to get the right number out of tens. But the problem with that expression, it's a little bit complicated. It would be good if we could just say tens and just put the number 20 in there, and that would give us 20, because then we know, yeah, 20 corresponds to TWENTY. And this is where dictionaries come in. Dictionaries, which we define with curly braces, like that, we can put in the values, 20, 30, 40, just as we did for the list, but we can also put a value in front of them, which is called a key, and the key colon, and then the value. And that means that we can use that indexing, so 10's 40, and that should give us the value FORTY. So let's run that and see. 10's 40 is 40. So that's good. Now these keys, they can be other data types as well. Here I've got them as numbers, but you can put letters, strings in there as well. So keys can be string. In this case, I've got A, B as corresponds to alpha, B is the key for the value Bravo, C is the key for the value Charlie. And I can print them, and that's what I get. And you can see here I used \n to give us the new line. And I just realized before when I was trying to do those backslashes back up here, which I can go back and fix. One of the problems I was having was because I was just displaying the values, and so that is actually correct. But if I wanted to see what a \n does, I'd have to put it in a print. And in that case, \n has dropped a new line. And so let's just say end of string here. And so it's dropped a new line, then I've done a tab, so it's tabbed in here, and then it's printed the rest of the string, end of string. So I hope I didn't confuse you too much with that. All right, what else can we use for keys? We can actually use tuples for keys. So here we're using 1, 4 as a key. And this is a case where it can be any immutable hashable type, and lists do not satisfy that requirement. So you can't use lists as a key because they're mutable. They're mutable means you can change it, but tuples are immutable, which means they're read-only, and so they can be used as keys. And so if I print that, here's my dictionary. It's got a tuple as the key. It's got a string as a value. Got a tuple as a key, a string as a value, and similarly another tuple as a key, string as a value. And here's an example of using a list. So anything starting with a hash, that's a comment. So I've commented this line out so it doesn't break for people to just run the whole thing. But if I uncomment it, you can see it breaks with a type error, and it says unhashable type list. So that key is unhashable, so it's not going to work. So I'll just put the comment back in there so that it doesn't break anymore. Okay. So if you want to add new keys and values, so remember D we defined up above. D is this one, A alpha, B bravo, C Charlie. And now if I say D and in the brackets I put a new key and then I put a new value over here, that will add the value into the dictionary D. So it's a mutable type as well. I can change D on the fly. I can add another key, E to epsilon. If I've got a whole bunch of keys and values, I can run a d.update and provide another dictionary. So here's another dictionary with E echo F foxtrot. And that gets run on top of D, and you'll have a look at what the merged dictionary looks like. And so A alpha, B bravo, C Charlie, D delta, so that came from here. E echo, so that came from here, and that overwrote the previous value that was epsilon. And then F foxtrot just got added on to the end. If you want to see all the keys in the dictionary, you can say d.keys. You want to see all the, so D is your variable, which is a dictionary, and then .keys is a function that you can run on any dictionary. You can look at values, you can look at items. So if I run that, let's have a look at what we get. So the keys, it gives me a list of keys, A, B, C, D, E, F. The values is also in a list, alpha, bravo, Charlie, delta, echo, foxtrot. And then the items are tuples of key value pairs. So that's pretty useful in different things. So we can loop through a dictionary. This is a for loop. We did fors in Getting Started 1, but we can do it here again. For loop, so when we say we have a variable name here, and that variable will change its value every time through the loop. We've got two commands in the loop, and they're both indented the same amount, so that's the code block that's in the for loop, and you can see before the code block we've got a colon up here that says I'm expecting a code block after this. And then I say in D, and saying D for a dictionary is the same as d.keys. So I could have said for K in all of these keys, A, B, C, D, E, F, find the value V, which is DK. So this is a new variable I've created, and I look up the dictionary by giving it the key K, and then I print what K and V are. And so K is A, V is alpha, then K is B, and V is bravo, C, Charlie, and so on. That's a fairly common thing that you'd want to do. It's so common that that's why you'd use dict.items, which returns these tuples that we saw before. And the tuple, we can have two values in here, and K gets assigned to the first value in the tuple and V to the second value in the tuple. And printing K, V will give us the same results as before. So that's just one line, saved one line in your code. So it just makes your code a little bit shorter when you use these techniques. Okay, task 2 is redo task 1 using a dictionary for the tens. So we've already defined the tens into a dictionary. This one here, yes. So let's do this. So I'll copy all the code that's here. And we'll stick this in here for our task 2. So now for tens, I just want to use tens of left. because left will be 20 in this case, and that will give us the name TWENTY. And that worked, and that's a little bit easier to read. Tens left, numbers right. And if I look at the solution, it was pretty much the same. So actually one thing I wanted to do here for this solution here, I'll do it without all these format codes because they're not that important. And so people, if I was wanting to, in fact, I won't even use format strings in case they're confusing you. So all I want to do here is going to be, I'm going to print out two things, one I and numbers I. This one's going to be I and tens left, and this is going to be I and Alright, so how would I do this without using format strings? I would have to say, so I could do, I want to do the number, then I want to do the dash, and then I want to do that. Oh, in fact, this will work. Yep. So these are three strings that I want to add together, which will just concatenate them. And that worked. 27 gives me 20-7. 52 gives me 50-2. So I've just taken out all the format strings in case they were confusing people, and that's what the solution would look like where when we're using this form of the print statement. So we're using print, we have a value and then a comma and then another value, and it just puts a space between them and prints the two values. So it prints the 27, then a space, then the words 27. All right, expand solution to task 2 to handle numbers up to 999. Test on these extra numbers. Okay, so we're testing on these numbers at the moment. So how would we do that? Let's take task 2 solution, and the first thing we want to do is see how many hundreds there are. And okay, just like we found the number of tens, which is the left number here, we can find the number of hundreds using integer division, although we won't use modulo. In this case, it'll be integer division 100. Okay, and then what we're going to do is print that number converted to a string and then the word 100. But if I do that, if I just say, let's just do it for this one for the moment. So numbers is those 0, 1, 2, 3, 4, 5. So if we go 300, and our value, and we'll add these extra numbers into our test. And I've got a key error. So, and then this right number equals I minus hundreds times 100. Or I could have done the modulo arithmetic there. In fact, I'll do that. And then this can be all based on remainder. Left, right, yep. Key error 0 on this one, 10's left. If right equals 0, yes, we'll just get rid of that for those cases for the moment. And I'm still getting errors. This one, a key error, oh yeah, on the 10s. Okay, so I need to sort out this 10s part. So what's right? 10s is on the left, but it could be 0. And the reason is when 10s is 0, I should be putting in, I should be not showing the 10s at all. So I could do it here. Remainder is less than that. Do numbers remainder, but then I'd have to put the hundreds in there as well. So it's getting a bit messy here. But I'm getting this 0, 127, 0, 152, 30, 101, 112, 301. That's all working. Let's try these with 100. 100 and 0, yet not quite working well enough. So you can see the problem's a little bit more complicated. So what we should do, we can see how it's done here in the solution. We can we get the hundreds name and we store that in a string, and the string can also be an empty string. So if the hundreds number is greater than 0, we store it in a string, and then if it's not, then we store the empty string and we don't have the AND. Now, the AND is an interesting one because that has to show when, well, we'll run this example and have a look at all the results. So if it's just straight 100, we don't want the AND, but if there's a number in the remainder, then we want to include the AND. So if the remainder equals 0, we leave conjunction out of the output, but otherwise we put it in. Okay, so it's actually a fairly complicated thing is how to name these numbers and to put it into code. So it's a really good exercise to work through that and see if you can get the logic, because you know the logic in your head, and see if you can get the logic right using these if and else statements so that it always prints out the correct value, and then just run it through some test cases and see if they always come up correctly. All right, so now we have some code which works for the numbers from 0 to 999. Yep, we do. But we don't want to have to copy out 18 lines of code every time we want to use it. So this is where we can use functions. We put all the code into a function and then we can call the function when it's needed. So what is a function? In Python, functions, you can tell you're calling a function because it's a name followed by these parentheses, left parentheses, right parentheses. That can mean that you're either calling a function or creating a class. There's nothing in Python that's going to tell you which one you're doing by looking at it. So what we generally do is we name our functions all in lowercase, and if it's a two-word function name, we put an underscore in there. And for when we're using class names, we'll do that in what they call title case. So it'll have uppercase characters for the first letter of each word and everything else lowercase and no underscores. So in this case, we're looking at functions. Print is a function even. So calling print, that prints a blank line. We can also use help. Is a function, and that will call up Python's help function. So that's pretty useful. And while I'm talking about help, we can also, to get out of that, we have to type quit, I think. Yep. And in Jupyter Notebooks, there's also a question mark for help. And that brings up help here on the right-hand side, which is, it tells you all about IPython. And you can do, here it tells you can do question mark in a word, and it'll give you help about that word. So I could do question mark print, and that tells me about the print function. Okay, all functions return a value, but for functions which are called procedures or subroutines in other languages, this return value can be none. The return value can be used in an expression or saved to a variable. So here, if we call the copyright function, and we can get the return value from that and store it in our variable, which we've called return value, and then print it out. By running the copyright function, it prints out all of this stuff. And then when we do our print statement, the return value from copyright is none. So it returns the value none, but we can store that return value. It's called none, but it's in the, we can store that in our variable. Functions take arguments, so you see we've been using print with arguments. Here's an example of using print with 3 arguments, and the arguments are separated by commas. And so if we run that, the print statement will print each argument and put a space between them. So there's a space there and a space there. I'll just close these help things. All right, we've been using format strings. When you use format strings, you're really using a single argument version of print, because the whole string is just a single value. There's no commas in the parentheses. So that is just an example of print with one argument. Functions can also have named arguments. So here's first 2 here are example of print with no named arguments. So it works out what each thing is by its position in between the parentheses. But when you put named arguments, you put the name of the argument followed by an equals followed by what the value of the argument is. It then will assign those values regardless of the position. And in some cases, and especially the print, so maybe not be a great example, some arguments have to be named and some arguments have to be positioned. So in this case, example of print, they're all positioned arguments because we use no names with no named arguments. And then example of print, and you can see here it's put dashes between each of those 3 words because we've filled in the named argument value of separator with a dash. So that says separate each value here with a dash and end with a space, not a new line. So it means that the next print statement will continue on the same line, and that's what we're getting. We get a space and then the same print statement, and the next print statement going on the same line. And it's using the underscore separator, and it ends with a less than, new line, less than, new line. And so you can see that string does in fact end with that. So that's examples of using named parameters, named arguments. Parameters and arguments are the same thing. and positioned arguments. Here are a few built-in functions. We've got the minimum function, just uses positional arguments. Sum will use positioned arguments, and it sums all the values in a list or a tuple. Max takes a whole bunch of positioned arguments and just returns the maximum value of those. And if you do max on a list, see what happens. Yes, so max on a list will also work. It iterates through the list and gives us the maximum value. Now you might say, why is lowercase c the maximum value of A, C and G? And that's because all the uppercase characters in Unicode and ASCII have a lower value than the lowercase letters. So the maximum value will always be a lowercase when comparing to uppercase. We want to have a look at the sum command and how the parameters work on that. Let's look at help on sum. And it says we have to provide a single iterable, and then we can provide a named parameter called start. And so by default, it will start with the value 0 and then sum up the other numbers. So in our value working with sum, it's started with 0 and then added up the other three numbers and given 83.4 plus 0 is 83.4. All right, so they're functions we've been working with. You can have functions that are attached to classes and data types. So for example, string is a data type. You can have functions attached to it like upper and lower and split. And those functions are called methods when they're functions attached to a class. So myString, which we just defined before as beginners Python and machine learning, we can convert that all to uppercase by saying myString.upper. And that gives us a new string with that value. It doesn't change the value of what's in myString. myString is still beginners Python with a capital B and lowercase other letters. Bob's Diner.title. We can see it looks for all the words in that and it's supposed to put a capital letter at the front of each one. It thinks that Bob is one word and S is another word, so it's put a capital S there. Not so great, but that's the behavior of title. Bob's Diner.split, that will split on white space in Bob's Diner, and so that'll give it Bob's as one word and Diner as the other. All right, let me know if I'm going too quickly or if you want me to go over any part of this. All right, now we can define our own functions. We're going to define a function which prints the current time. To find out what the current time is, though, I'm going to need to use this library. It's a standard library called datetime, but what's included in the datetime library is not available by default, so I have to import it. And once I say import datetime, it means that anything in datetime I can now refer to by putting datetime dot at the beginning and then anything inside that. So datetime's a little bit of a confusing one because inside datetime they've got a class called datetime, the same name, and inside that class has got a function now. So that'll tell me what the current time is now. So if I define this function by using def, and I've given it a name show now with parentheses, I've now defined it, but nothing happens when you define a function. It only happens when you call the function. So show now will call the function because I've put the function name and followed by the parentheses. And so if I run that function, it says the time is now, and it's the 1st of September, and in Universal Coordinated Time, that's 8:33 in the morning. Okay, so that's defining a function with no arguments. We can define a function with one named argument, degrees Celsius, and it's called degrees Fahrenheit. So the user using this function will provide a value there for what the temperature is in Celsius, and this function will return the value in Fahrenheit. So I can define that function by executing that cell. If I don't execute that cell, it won't be defined. And then I can run it, and I can call it by the function name, degrees Fahrenheit, followed by parentheses, and inside the parentheses I put the value that I want to convert. And I've just messed that up. So here my cell values of C are 0, 100 and minus 40 in degrees Celsius, and convert that to Fahrenheit. That's 32 degrees Fahrenheit, 212 degrees Fahrenheit, and minus 40 degrees Fahrenheit. All right, so we'll talk a little bit more about some advanced features. So if you're brand new, you don't have to worry about this so much, but a lot of you have noticed have been doing these Python courses before, so I can let you know about these. Python's starting to use a thing called type hinting, where you can define the types that you want. So I want to say the type that I'm providing for Celsius is a float. Now this is just a hint, it's not a requirement. But it helps your integrated development environments to generate warnings if you start to provide values of the wrong data type to a function. And I also say I want this function is going to return a float, so that it's once again it can generate warnings if I use the return value in a way that it's not would not make sense. The first line after you define a function, you can put a string. So you put a string opening with quotation marks, and here I've used a special version of this Python string, which is a triple double quoted string. And what that means is that I can put carriage returns and line feeds inside the string, and so that I can have a multi-line string there, and it doesn't stop until it gets to the same quotes that it started with. The advantage of doing this is this string will be treated like a doc string, so that then people can run help on your function and get information about it. So if I define this new function, degrees Fahrenheit, by Shift Enter, and now I call help on this function that I've just defined, you can see it's got the doc string here. It tells me returns temperature in degrees Fahrenheit given the temperature in degrees Celsius. And I've also just put some extra bits of doc string in there, showing what you can do with a triple double quoted string. It even puts the types in there to give you a hint about what type you should provide to it. So that's one way of looking at the doc string if you're looking at it interactively. If you want to find it from your Python code, you can actually use this property of the function. You say degrees Fahrenheit, this time without parentheses, because we're referring to the function, not calling the function. And then I want to find the doc of that function. And there is the string there. You can see with new lines, and there it is. It doesn't give you the type hints. It just gives you that doc string. So we could keep calling it as we did before, like I've now redefined it. So if I run it up here, it should still run like normal. Yes, it does. That's using the new definition of degrees Fahrenheit. But it will still work even if I present the wrong data type. So in Python, you can use complex numbers as a data type just by saying a real part and an imaginary part. So it's a real part plus a value, the imaginary part, and then a j there. So if I say the complex number 24 plus 5j, and I pass that into my degrees Fahrenheit, that will just go straight ahead and tell me that in degrees Fahrenheit, that's 75.2 plus 9j, a complex number. Obviously that makes no sense, But if you want to, you can check that that is the correct answer. So you'll probably find that 5 times 1.8 gives you 9, which is correct. 24 times 1.8 plus 32 will give you 75.2. So it's done the complex arithmetic correctly, and it doesn't matter that we've defined these types, they are just hints. But if we wrote that line in an IDE, it would generate a warning and say, what are you doing sending a complex number to that function that's only designed for floats? All right, so let's define our own function. So we'll convert the code from task 3 into a function and return a string. So let's find task 3 solution. All right, so our loop, we'll do that after we've defined the function. And we'll say print name of number I. So our function is going to be called name of number. So let's define it up here. Name of number I, and parentheses, we put in our argument, which is going to be I, and then we'll put in a colon to say start a code block. And there's our code block, it's all indented. And we want to return a string from this. That's going to be the result. Now we've got 4 print statements here, 4 places where we could potentially return from. So we could actually just put a return in each one of those. And we don't want to print the result. We want to just return a string. So what we're going to do, we're going to do I, comma, name of number there. The only bit of the string that we really want to return is this last bit here. So let's just do that. Okay. I'll just copy that. And we're just going to use that there, 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 and get rid of these parentheses. So we're sending in the number 27, we get 20-7, 52, 52, 55, 12, 12, 30, 30, 100, 112, 300, 999. Right, so now whenever we want to get the name of the number, we can just call our function name of number, give it the number that we want, and it will convert it into text for us. Let's have a look at our solution here, see if there's anything different in that one. So remember what we did here, that all looks pretty much the same. Okay, so here we didn't use format strings for returning. I don't think it matters which way we do it. Both would work. We did put a format string for the output at the end. So this one used string concatenation with plus signs, but we used, up here we used format strings. So it's both work. All right, expand solution 4 to handle thousands up to 20,999. Okay, let's take their solution. Right, so we want to go up to 20,099. So let's try this. We want to Okay, and we can just copy this code here. And number minus equals thousands times 1000. So thousands name equals numbers thousands followed by the word thousand. We don't need any conjunctions for thousands, that's only between hundreds and the rest. And then we just have to add this in. If number equals 0 and hundreds names does not equal null, does not equal empty string. So in that case we want to say if thousands name plus hundreds name does not equal that, then return thousands name plus hundreds name. And we'll check for 20,999. I tried to make shortcuts. Okay, if hundreds is greater than 0, yeah, that should be thousands. $20,999, and let's add a space on the end of 1000, just because we add a space on the end of and there. And so that worked. Is it possible to have only one if in a function? Yeah, well, we had a, I mean, you could have 0 ifs. Our degrees Fahrenheit function only had no ifs in there. So we could have put an if in there. What's an example of what you're really asking? You can have as many ifs you can put ifs in a function. You can put for loops. You can put loops in there. So, so if you want to have nested, like you can indent as many times as you like. So we've indented when we defined the function here, and now we've come to an if statement, so we've had to indent again. Now, if we had another if inside that if statement, we'd be able to indent again. And then if we had a for loop inside that if statement, we'd indent again. You can just keep indenting for every as many times as you like, if that's what your question is. All right, so we've got up to 20,999. Let's see how we did that. Yeah, so we had a bit of code here that we repeated, which was thousands name plus hundreds name, and we put that in lots of places. In the solution, they worked out that that was a common thing, so we created a string S here that had the thousands name on it, and then it added on the hundreds name onto that as well. And then we could just check if S does not equal an empty string. We just return S. Otherwise, we'd return these. Does the function skip the element in the list? Okay. So if you call a return function halfway through, if you call a return command halfway through a function, it will skip the rest of the function. The rest of it won't run. So once you've returned, so I don't really need an else if in this case. I could just go straight back to a normal if, because it won't get there. If this one turned out to be true, then it would never get to this next command. So I don't even need else if. I could just put if there. Yeah, return does skip the rest of the function. How can we handle numbers up to billions? Right, so let's have a look at solution 5. And I'm going to go through the solution here that'll get you up to 999,999. So you can see here I'm calling numbers thousands, and this is where the limit is, because if I get to 20,000, if I get to 21,000, then this is not going to work. So what I need to be able to do, I need to be able to call a function that returns a name of a number up until 1,000 to tell me how many thousands I've got. Now I've already got a function to do that. That's this same function. And so I would be calling itself. Now that's called a recursive function. So rather than numbers thousands here, I put in number name thousands. And then this number name here calls back to the same function. And so let's put in some test code here. So we want 123,456 and 999,999. So just with that one change, 123,456, I've now expanded the values all the way up to 999,000 from 20,000. But I'm stuck now. If I want to go above 1 million, I've got to put in some extra code here for millions and calculate the millions. And I could do that, but I'm starting to notice a pattern here. I've got this section for the thousands, which looks very similar to the section for the hundreds, apart from the and there. And if I did a section for millions, it would look very similar again. So I'm not going to go through, I'm not going to show you how to write that function, but I'll show you the solution, a solution that will do it. And actually the solution that takes us up to trillions is shorter than all the ones that we've been doing up until now. And so how it works is we store all of these values, the 100, in a dictionary called powers, and then we have a loop here to loop through these items in the powers and see if it can, if the number is greater than that. So if it's greater than 1 trillion, then it would pull that value out. Otherwise, if it's greater than 1 billion, it will pull this number out. And we've defined the dictionary here, and we can, because it's been defined in that order, we know it'll go through in that order from trillion to billion to million to thousand to hundred. Now that's only a feature of 3.6, Python 3.6 and below. If you wanted to, if you're using 3.5 or earlier, we don't know which order these would come, and we would have to do it a different way. In which case, you would have to create a list of the keys and sort and make sure you're going through them in order. But now, since Python 3.6, we can just rely on the dictionary being in the correct order. and we just keep adding on to this string by the name of the power and how many of that power. And then we can just check if we need a conjunction at the end. So actually I think my last one I didn't get quite right for 1005. I don't think I would have had the conjunction in the right place in my solution. Let's test 1005. Oh yeah, I did get the conjunction in the right place in solution 6. Solution 5, I don't think I did. Oh no, it's all right, all good. Anyway, they're just the sort of edge cases that you have to be careful of. So this looks good. Let's try running that and just see how successful it is. Yeah, I thought it would go more than a trillion. So 12,345,678,901,234. So when it says 0 to 1 trillion, that should actually be 1,999 trillion. Okay, so have fun with that one at home. But let's move on to this next one, task 7. We're going to try to improve on the string.title function. We want to convert Bob's Diner into Bob's Diner, so we just want a capital B and capital D. We don't want a capital S, because we found before when we did Bob's Diner, we got a capital S. So think how you might do that. We can use the split function, which we tried before. So S equals Bob's Diner, S dot split. That'll give us a list of words, and when you've got a list of words, you can loop through them. So let's define our function. We'll call it title from a sentence. So we'll create a list of words by splitting it. And we're just going to split on spaces, which is probably what you would want to do in this situation. And then we're going to loop through all the words in that list. So I'll create a for loop for word in words. So here we got words as a list, so word will be an individual word, and we're just going to title on, we're just going to convert the first letter of each word to uppercase. So let's create a new list. We'll call it list of new words, and that's an empty list. And we're going to append that list with our word, but we're going to take the first character of the word, which is index 0, and we're going to convert that to uppercase. And then we're going to take all the rest of the characters of the word, so from 1 on to the end. So I'll slice from the first to, and by leaving the end of the slice blank, it will go to the end of the word, and have that in lowercase. Okay. And for now, I'll just return that list of words, and we'll print title of S. So that's looking good. It's got a list of words and it's made the B capital, all the rest lowercase, the D capital, lowercase. And now what I want to do is join all those words up with spaces. And so we use the join function of a string, which is take a space and use that to join all the items in an iterable list with that space. And so that's given me a string with the space in between it. So this here, like I could have put a colon in there and that would join everything with colons. That's all it does. If there's more than one word, and motel, it just puts colons between all the words that are there. All right, but space is what we really want. All right, so once again, this is a thing that you would do quite frequently. You create a new list, then you loop through another list and keep appending some transformation on those old values of the list into the new list. And in Python, they've got a way of compacting those 3 lines into one, and it's called list comprehension. So what it does, you open the square brackets there and close them there. So that's those square brackets there. You grab your loop or whatever you want to do and you put that in that part of the square brackets, and then you take the bit that you want to append and you put that at the beginning here before the 4, and that's just compacted those 3 lines. So you might see this. If you're an absolute beginner, I'd be using the top way for doing it for now, so that it's a bit easier to read for a beginner what is actually going on. But as you get more competent in your Pythons, you can start using list comprehension, and you can start making your code even shorter. So let's check how that worked, and yep, that worked. And I'll make it a longer one. Let's check that works as well. Yep. Default values in functions, they can have, so if we want to find help on the split function, we can't just do help and split, because split is part of string, so you have to do help string dot split, and then remember, don't put the parentheses there, and then that will give us help on that split function. And you can see here it's got separator equals none as the default value, and max split equals -1, but both of those named arguments you can change. So you can change the separator. If the separator is not specified, then any white space string will be the separator. Otherwise, it will use what you've got there. All right, so say we want to rewrite solution 7 to have a named argument sep with a default value none, and that argument will just get passed straight on to split. What would be the solution for that? And that's pretty simple. I'll just take this function here, and I just put in a named argument. So sep equals, or sep is a named argument, just like sentence is a named argument, and I can put a default value on it by saying sep equals none, so that's the default value. And then when I split here, I can pass through that named argument. So I can call their named argument, which is sep, and give it the value of my named argument, which I've also called sep. So to test that, title, let's separate on n. So I want n, anywhere there's an n, that's going to be where I want the uppercase characters straight after. And there we go. So the N got taken out and I got a capital E. The N there got taken out, I got a capital D. So it's done title at the beginning and on every place where there was an N. Now you might actually want the N to come back in. So in the solution here, in solution 8, if step is none, then just join it with a white space as is the default. Otherwise, join it with the actual separator character. And in this case, we've used underscore as a separator character. And that's put the underscores back in, but put capital letters after. So just fun things you can do. Okay, so if you're an absolute beginner, you've done really well to get this far. I'll quickly run through these things. This is for more advanced users. You can put, and it's all about packing and unpacking of arguments. So, yeah, I'll just run through it quickly. When you're providing positioned arguments, you can put them in the right position between the parentheses, but sometimes you might have all of them already in a list, so you can supply that list to the function and then say just unpack that list into all the different arguments. And the way you do that is you put an asterisk in front of the list and that will unpack them. So you can see here, if I didn't have the asterisk, I would have to do, I want to run the split function, I want to use /t as my separator, and I want maximum number of splits to be 4. So I would have to use list args 0, list args 1 to put in those two position arguments. But by just putting an asterisk in there, that unpacks it into the list into those things and can be used that way. So let's try it and see what we get. So if my string starts off with is TSV, tab separated values, first one, second, third, fourth, fifth, sixth. My list of arguments is going to be \t for tab, and I want only 4 splits to happen. Then if I do this, I will get the split in the right place, but I can also get the same effect by using asterisk args, and it gives me the same effect. Similarly, I can do it with, what am I showing here? I can do it with tuples. If I use a tuple args, which is just my favorite, and I want to use the print command, and I print that, it prints the tuple. But if I unpack the list, it separates them out into my and favorite and uses the colon between them as the separator for the print command, and I get my colon favorite. All right, so that's positioned arguments. If you want to define your own function with positioned arguments, so not named, you can put an asterisk in there, and that will take all the arguments that get given to it and pack them up into a list called args. So in this case, you provide all of them. I could have done that by unpacking a list, but in this case I'll do 4, foo bar, and that works. I can't do args equals 4, that will fail because this only works for positioned arguments, it doesn't work for named arguments. Similarly, you can use double star notation to pack and unpack dictionaries. So here's a dictionary where I've got a keyword and a value, a keyword and a value, and it will use that as a named argument and the value of that named argument, the named argument and the value of that named argument when I call the function using ** keyword args. And so that worked. I'm just racing through this just so, because you'll probably see this notation and you'll just be wondering what it's all about. Similarly, if you want to define a function that uses non-positional named arguments, you can use the ** notation. So this means that they have to provide named arguments. They can't provide position arguments when they're calling this function. But there's no limit on what they name their arguments. So in this case, we're going to name it A equals alpha, B equals Bravo, C equals Charlie, and it gets printed out our dictionary that way. And if you really want to get advanced in Python 3.8 and later, you can define position only or keyword only arguments using slash and star in your function definitions. So this is your standard named argument, so they can be used as named or positioned. Slash there says anything before a slash is going to be position only. You can't use the named argument arg in that case. Anything after a star is going to be a keyword only. And if you want to have a combined example, you can have a few arguments that are position only, followed by a slash, followed by some standard arguments which can be position or named, followed by a star, which means that anything after the star has got to be keyword only. So that's the end of today's session. I hope you enjoyed it. I hope you learned something. So yeah, if you like that, click like on the video. I'm still happy to listen to questions on the YouTube chat and on the Slack channel. I think once I stop the video recording, the YouTube chat will stop to work, but you can still keep asking for a few minutes on the Slack channel. All right, thanks, Pete. I've got thank you from Peter. And next week is going to be Arun. He's going to be doing the next 2 weeks, which are going to be machine learning. And then I'll come back. I'm not sure what I'll be doing in 3 weeks' time, which will be something just more standard Python based rather than machine learning. Okay, thank you very much.